Today we're going to be doing solving simultaneous equations. This example, how much do the burgers cost, how much do the fries cost? So let's have a look at it. We've got a burger plus another burger plus a fries equals £5. We've got a burger plus a burger equals £4. I would say, right, well, if two burgers cost £4, that these two burgers cost £4. Now, my total is £5. So to make that from £4 to £5, I need to add another pound, don't I? So my fries must cost £1. So my fries cost £1 and two burgers cost £4. Now, if two burgers cost £4, then if I divide that 4 by 2, 1, 2, that burger costs £2 and that burger costs £2. Okay? Now, this is how simultaneous equations work. This is just an example of how they work in real life. Let me show you this graphically. I want to work out the value of one orange bar in each of these diagrams. So I know this first one, that orange bar plus that orange bar plus that orange bar plus that blue bar that's 4 equals 19. So what I would do, first of all, I want to work out what one of these individual bars is. I would take my 19 and I would subtract 4. That would give me 15. So because I've got rid of that 4 now, I know that and that equal 15. So 3 of these orange bars equals 15. So what I'm going to do is I'm going to share or divide my 15 equally between these three. 15 divided by 3, it's 5. 5, 10, 15. I can check my answer. So 5, 10, 15 plus 4 gives me 19. You do 22, take away 6, then divide that answer by 1, 2, 3, 4, meaning each one of these is worth 4. And again, add them all up together and we should get 22. For the final one, so we have 23. We minus the 5. Well, this is with 18. We then divide that by 1, 2, which leaves us with 9. 2 9s are 18. So 9 plus 9 is 18, plus 5 is 23. Simultaneous. This is just pulled straight from the dictionary, and what it basically means at the same time. So simultaneous equations are two equations with two unknown numbers. And what I mean by unknown numbers, it could be an x and a y, it could be an a and a b, or a C or a D, yeah? As long as they're different, and there's two of them, these are called simultaneous because we've got to solve them both at the same time. Let's have a look at an example, shall we? Solve. 4x plus y equals 17. 2x plus y equals 11. Now this looks completely different to this little bar thing we did. But what we can do, if we prefer that visual representation, we can create little bars for ourselves, can't we? So I've got 4 x's and 1 y. That equals 17. So I've got 1, 2, 3, 4 x's, 1 y equals 17. The next one, I've got 2 x's plus a y equals 11. So 2 x's plus a y equals 11. Now remember, the idea of solving simultaneous equations is to find out what 1x is and what 1y is. Now there'll be different values in most of the cases. So what we're going to have to do first is we're going to subtract this bottom one from this top one. So I'm going to take away a y from both sides. I'm going to take away an x from both sides. I'm going to take away another x from both sides. And what I'm also going to do is I'm going to do 17 take away 11. That's just left me with these two. So 17 take away 11 is 6. That take away that is nothing. That take away that is nothing. That take away that is nothing. That just leaves me with that and that. So I know that these two x's equal 6. If two x's equal 6, one x is 3. So now I know that these x's each equal 3. So I can replace those x's now, can't I, with the number 3. There we go. I've now got 3. So what I've done is I've taken this top equation, I've replaced the x's with 3. That just leaves y on its own, equals 17, just like that. What I could have done, I could have just taken the bottom one and then replaced these two x's with 3 plus y equals 11. Doesn't matter, yeah? But I've just chosen the top one for this example. So I've got 3's where the x's were and a y. Now, I'm going to get rid of these 3's. I'm going to minus them. So 3, 6, 9, 12. So all these added together, these 3's equal 12. So I'm going to minus 12 from this side. Okay. So 17 minus 12 gives me y equals 5. So now I know I've solved this completely because I've said x equals 3 and y equals 5. If I really wanted to check, what I could do is I could take the bottom one and I could say, right, 2 times x, so x is 3, so 2 times x, which is 6, so 6 plus y, now y is 5, 6 plus 5, does it equal 11? Yes, it does. We'll go through another example. So in this case, I've got 2x plus 5y equals 23. I've got 2x plus 3y equals 17. I want to find out what 1x is and what 1y is. I'm just going to put the graphical representations here for you, if it makes it easier. So I've got my 2x's and my 5y's. I've then got my 2x's and my 3y's equals 17. So what I'm going to do is I'm going to subtract what I can. So we're going to get rid of that one and that one, 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 that one and that one. That just leaves me with 2 y's. Okay. Now remember, if you think back to when we did solving equations, whatever we do to one side of the equal sign, we do to the other. So this time I'm doing 23, take away 17. So I've taken away all these, and I know these are the same value as these. So I'm doing 23, take away 17. That leaves me with these two on their own, which equals 6. Again, same as before. I just want to know what 1y is. I know 2y's are 6. So 1y has to be 3. 3, 6. Pick any equation, doesn't matter which, the top or the bottom. I'm just going to pick the top one. Yeah, just because it's at the top. No particular reason. Could have easily picked the bottom. So I'm going to pick the top one. And I'm going to replace these y's now with what I worked out y as, which was 3. So x plus 3 plus 3 plus 3 plus 3 plus 3 equals 23. Now, I know that all this together equals 23. So what I'm doing now is I'm going to take away these 3's. 3, 6, 9, 12, 15. Because I want the x on its own, remember. So I take away 15 from this side, I take away 15 from that side. So that leaves me with 2x equals 8. Now again, I don't want 2x, I just want 1x. So what I'm going to do now is I'm going to divide my 8 by these two x's equally. So 8 divided by 2 gives me 4. So x equals 4. So that's the easy bit. Sometimes we have to solve these linear equations by elimination. Because if you notice, in those examples that we did, either both x's have the same coefficient. Remember, the coefficient is the number before the letter when there's a number and letter together. Either x had the same coefficient or y had the same coefficient as the other equation. Obviously, that's not going to happen all the time. Sometimes they're going to have different coefficients. So we're going to have to scale them up to make sure they have got the same coefficients. When we're doing this, we need to take two things into consideration. If the sign's the same, then we're subtracting them. I'll show you some examples. If the signs are different, we're going to add them. So let's look at some examples. So here I've got 5x plus y equals 20 for that first equation. For the second equation, I've got 2x plus y equals 11. So first of all, what I need to do is I need to make sure that I've got the same coefficient in both of these. Now I have got the same coefficient for one of the letters in both of these. It's the y. They're both 1y, aren't they? So I don't need to scale up for this one because they're both the same coefficient. Now, look at the sign there. We have a plus there. We have a plus there. So they're the same. The symbols are the same. So remember what we said? We've got 3x because we're subtracting, yeah? Because these are the same. These symbols are the same. To subtract. So we're doing 5x minus 2x. That gives me 3x. So just bear in mind we're doing the same thing. The only difference is that we're not using the little blocks anymore to visualize it. I've then got a y there. I'm going to minus the y. So if I have a y and a minus a y, that leaves me with nothing, doesn't it? It's completely blank. Cancels itself out. And then finally, 20 minus 11. So I bring the equal sign down, and that gives me 9. So 3x equals 9. I can then solve that equation to find out what x is. So what I do is I do 3x divided by 3 gives me x. 9 divided by 3, because I've divided this side by 3, I have to divide this side by 3. So 9 divided by 3 is 3. So x equals 3. Okay. So remember, these are the same signs, so it's a subtract. Now, once I've worked out what x is, what I can do is I can substitute either the x in here or the x in there for a 3. So just as before, what I'm going to do is I'm going to pull the top one. I could use the bottom one if I wanted to. It doesn't matter. But I'm just going to pull the top one down. So I've got 5x plus y equals 20. Now I know that x equals 3. So remember, a coefficient and a letter together means 5 times by x. Now I'm replacing x with 3, so it's 5 times 3. So 5 times 3 is 15. So I'm just going to write it again underneath. 15 plus y equals 20. So I do 20 minus the 15. That would leave me with y on its own. So y equals 5. So I've worked out what x is. I've worked out what y is. Now let's have a look at something different. All right. This time we've got the symbols here that are different. I don't need to scale up in this case because, again, I've got two coefficients that are the same, the two y's. It's the same there as it is there. Now this time, like we said, we've got a plus and a minus. So these signs are different. Okay? So because they're different, we are going to add. Remember, if it was two minuses, it would be subtract. If it was two additions, it would be subtract. But if it's an addition or a subtraction and an addition, we add. Okay? So, I'm doing 7 add 3, which will give me 10x. I would then do, pop it in, 10x. Okay? I've then got 2y plus minus 2y. Now be very careful, yeah? If I've got 2y and I'm adding a minus 2y, so what's going to happen here is I'm going to start with my 2, my positive 2. I'm taking away 2. That leaves me with nothing, yeah? Because I'm adding a minus 2. A little bit hard to get your head around that bit. So I'm starting with a positive 2 and I'm adding a minus 2. So that would take me to nothing. I then bring my equal sign down and I do 32 plus 8 equals 40. So I've got 10x equals 40. Now I can solve the equation, can't I? I want x on its own. Depends which way you do it. What I tend to do is I say, well, I want to get rid of the 10 from the 10x. So I'm going to, remember it's 10 times x. I'm going to divide by 10. Divide by 10 this side, divide by 10 that side. If you feel more happy with saying, well, it's a times by 10, I'm going to move it over to this side. It's going to be a divide by 10. It's up to you how you do that. I don't mind. I just find it easier this way by dividing by 10, dividing by 10. So I now have x equals 4. Yeah, whichever way you do it, you still get the same answer. So x equals 4. Now, again, I can either pick the top or the bottom. It doesn't really matter. So what I'm going to do is I'm going to drag the top one down again. So I've got 7x plus 2y equals 32. Now, because I know what x is, I'm going to substitute the x here for 4. So instead of 7 times x, it's 7 times 4. Okay, so I'm just going to write that underneath my 28. So I've got 28 plus 2y equals 32. So what I'm going to do next is I'm going to solve it. So I'm going to get rid of what I can. So I'm going to get rid of 28 on this side, but because I'm minus 28 on this side, I'm minus 28 off this side, which leaves me with 2y equals 4. Again, I only want one y. So what I'm going to do is I'm going to divide my 4 by 2. Yeah. Or another way of doing it is 2y. I want to get rid of the 2. So it's 2 times y. Divide by 2 this side. Divide by 2 that side. So y equals 2. Y equals 2. So let's have another look at another example. The problem with this example, now so far I've had one of the coefficients the same. Either the x's were the same or the y's were the same. This time they're different. All right. So what I need to do is I need to make either the x's the same or the y's the same so I can get rid of one. Now the easiest way to do this is by scaling it up. Okay, I've got to scale up one of these, or if I can't do it just by scaling up one of them, I have to scale up both of them. Now when we scale them up, we multiply. So when I'm going to multiply, I'm either going to multiply everything in this one, or everything in this one, or everything in this one, and everything in this one together. Okay. So what I'm going to do here is, if you can see, I've left this one as it is. So I've multiplied this by 1. 1 times 12x is 12x. 1 times minus 2y is minus 2y. 1 times 8 is 8. So that's done, you know, straightforward. This one, what I've done is I've multiplied everything here by 2. So I've done 5 times 2x. 5 times 2x will give me 10x. Y times 2 gives me 2y. 18 times 2 gives me 36. Now, can you see now how I've got the same coefficient for the y's? So I've times the first one just by 1. I've times all this second one by 2. Okay, you don't have to times them both by the same number. We only have to do it once. It's going to be the same. Now this is because we're working in proportions. Because I've times everything on here, we're still going to get the same right answer. So I've times everything on this bottom one by 2. So I've got 10x plus 2y equals 36. What I can do now is I can move on to my next point, which is look at the signs. Are they the same or are they different? All right. So because they're different, we know we're going to be adding them. If they were the same, we will be subtracting them. But because they're different, we're adding them. So let's continue as we did before. 12 add 10 would give me 22x. I've got a minus 2 and I'm adding a positive 2y. So I've got a negative 2y and I'm adding a positive 2y. So if I start on minus 2 and I add a positive 2, that takes me to 0, doesn't it? Think of a number line. All right, so they've cancelled each other out now. I've got 0. I bring my equal sign down and I do 8 add 36. Okay, so now I end up with 22x equals 44. I divide by 22 this side, I divide by 22 that side. That leaves me with x equals 2. Brilliant. Now, I've worked out what x is. I need to work out what y is. All right. So again, I pull an equation down from the top. Doesn't matter which one. I just tend to go for the top one, really. So I've got 2x minus 2y equals 8. Now I know x is 2. So I've got 12 times by 2, 24, minus 2y equals 8. So I'm just going to write that out again, but having done this 12 times 2. Okay, so 24 minus 2y equals 8. I'm then going to get rid of this 24. So I'm going to subtract 24 from this side, 24 from that side. So that leaves me with minus 2y equals minus 16. Again, I don't want minus 2y, I just want y on its own. So what I have to do is I have to divide by minus 2. So I do minus 2 divided by minus 2, that just gives me y. Remember, two negatives make a positive. Again, I've got minus 16. I'm dividing that by 2. Or minus 2, should I say. Two negatives, I'm going to make a positive. So minus 16 divided by minus 2 gives me positive 8. All right. This kind of thing I cannot see on a non-calculator. When I've seen these before, they've always been on calculator papers. All right. It is possible for it to come up on a non-calculator paper. However, if it does, it wouldn't be minus numbers, I don't think, like this. To be a nice straightforward one. Okay, so let's have a look at this one. I've got 7x minus 3y equals 29. 2x plus 5y equals 20. Now, step 1. Have we got the same coefficients? No, we haven't. Can I multiply any of these coefficients here to get that coefficient? Or can I multiply any of these to get that? No, I can't this time. Okay. So what I'm going to have to do is I'm going to have to multiply both of them. So this is why it's important for you to practice over and over again your times tables. All right. I can't stress that highly enough. That's why there's so much emphasis now on learning timetables off by heart in primary schools. This is one of the reasons. So what I'm going to do is I'm going to have to scale up, but not just one of them. I'm going to have to scale up both of them so that I can get the same coefficient. So what I'm going to do is I'm going to multiply 7 by 2 because I know 2 7s are 14. And I know that I can multiply 2 by something to change that into 14. So what I'm going to do is I'm going to multiply, like I said, that 7 by 2. Now, because I've multiplied that 7x by 2, I have to multiply everything on that line by 2. So 7x multiplied by 2 gives me 14x. Minus 3y multiplied by 2 gives me minus 6y. And 29 multiplied by 2 gives me 58. I now need to get this 2 to a 14. This 2x. So what I'm going to do is I'm going to multiply that by 7. Yeah. If I do my 2 times tables, up to 2 7s are 14. So now I've got that as 14. But because I've multiplied that by 7, I have to multiply everything else by 7. So 5 times 7, 35. 20 times 7, 140. Now I've got the same coefficient here, I can progress on to the next step. Now remember, the next step is is it a subtraction or is it an addition? Well, these signs are different, aren't they? Okay, so it's a subtraction. So I'm doing 14x minus 14x. That gives me nothing. All right, that's cancelled that out. So then I have minus 6y minus, I'm taking away, plus 35y. Okay, which leaves me with minus 41y. And then I've got, finally, 58 minus 140 gives me minus 82. Now, please don't be afraid in an exam. If you struggle with your minuses, your minus numbers, do a number line. Okay? If it helps you out, do a number line. There's no shame in using a number line. Plus, if anything, you'll get marks for it because it's showing you working out. Now we solve the equation. So again, I want to get y on its own. I divide by minus 41 this side. I divide by minus 41 that side. So minus 41y divided by minus 41 will give me y on its own. Minus 82 divided by minus 41 gives me positive 2. So y equals positive 2, or y equals 2. Again, I then pick one of these, either the top or the bottom. And just as before, I'm going to pick the top one. Okay. So I know what y is 2. So I've got 7 times x minus 3 times y. Now remember, y is 2. So that's now going to be 7x minus 6 equals 29. All right. So what I'm going to do now is I'm going to get rid of the numbers. So I want to get rid of this minus 6. How do I turn minus 6 into 0? I add 6. So I add 6 this side, I add 6 that side. That will give me 7x equals 35. I just want x on its own. So I divide by 7 this side, divide by 7 that side. So I end up with x equals 5. Okay. Again, if I really wanted to, I could check it by using this second equation. All right. So I know x is 5, y is 2. So 2 times x, 2 times 5 is 10. So that will be 10. 5 times y is 2. So 5 times 2 is 10. So 10 add 10 equals 20. Yes, spot on. All right. And it's just a worded question. It's exactly the same as we've done before. It's just worded. Now it says a cinema sells adult tickets and child tickets. The cost of 3 adult tickets and 1 child ticket is £30. The cost of 1 adult ticket and 3 child tickets is £22. Work out the cost of an adult ticket and the cost of a child ticket. So the first thing is I'm going to write these out as equations. So we've got adult tickets and child tickets. What I'm going to say is I'm going to call adult tickets A for adult and child tickets C for child. So the total cost of 3 adult tickets, so I'm going to call that 3A, and 1 child ticket, so add 1 child ticket. That's going to be add C. Remember, it's add 1C, but we never show the 1, so it's just add C is £30, so equals £30. So I've got 3 adult tickets. All right, 3 adult tickets plus a child ticket equals 30. That's the £30. The next one, the total cost of 1 adult ticket and 3 child tickets. So that's going to be 1 adult ticket, so 1A, or as we say, just A, and 3 child tickets. So that's so it's plus 3C is £22, so equals 22. So I've got 1 adult ticket, A, plus 3 child tickets, which is 3C, equals 22. So they're my 2 equations. Okay? They are my 2 equations. So what I've done now is that I've done, well, have I got the same coefficient? No, I haven't. I haven't got the same coefficient. Can I make one of these into the same coefficient? Yeah, I could make the A's the same, or I could make the C's the same. So what I'm going to do is I'm going to make the C's. And the way I'm going to do that is I'm going to multiply everything in here by 1. So I'm basically going to leave it. I'm going to multiply everything here by 3. Okay, so 3A plus C equals 30. That's the top one. 3A plus 9C equals 66. So I've multiplied everything by 3 on this one. Yep. What I can do then is I can continue doing the steps we did before to work out what A is and what B is. Now, this is the last one. I'm not going to go through this because I've gone through this quite a few times.